Okay, finally, let's just observe a general overlook over the course, what we're going to cover throughout this course. So we'll start in the next lecture, we'll start discussing stateless decision processes. So we're confronted with the same decision over and over again, and we don't actually transition between states. That's a very simplified version of a reinforcement learning problem, but the reason that I'd like to start there is because the solutions that we're going to see for that simplified problems, it will give us a very good basis to later generalize those to general MDPs. So that's where we're going to start. Next, we're going to discuss the more general Markov decision process, and then we'll start discussing different ways to solve MDPs. We'll start with what's called tabular MDPs, so not the deep version. With tabular MDPs, we'll see some, again, basic solutions that we will later generalize to deep reinforcement learning and to non-tabular cases. We'll see, in order to solve tabular MDPs, we'll discuss algorithms that follow dynamic programming, and we'll see how to use temporal difference or Monte Carlo approaches in order to compute. These are the estimations for solving tabular MDPs. Next, we're going to discuss policy gradient approaches that includes that can be used to optimize functional approximators for an actor critique architecture, and eventually for deep reinforcement learning to include deep neural networks in the mix. So our next class will be, we will cover multi-arm bandit. These are stateless MDPs. So it's the same state over and over again, as I just explained. For the assignments, you should start by going over the tutorials that I discussed in the beginning of this class, specifically covering linear algebra, basic probability, Python, NumPy, and the gymnasium tutorial by OpenAI. And for your project, you should go over the project description and timeline. These are, as I said, initially they are available in the course's website, and find a partner to work on the project with.